In this video, we'll be going over the midpoint and distance formulas. So two key terms that you'll need to understand in order to access these formulas is our midpoint and our segment bisector. A midpoint is a point on a segment that is equidistant from each endpoint. So for example, in this drawing below, point M is the midpoint because it is equidistant from both A and B. We can see this with these red tick marks here, since they're both one tick mark long. Then they're identifying that those segments AM and MB are both congruent to one another. A segment bisector passes through the midpoint of a line segment and cuts it into two congruent segments. So this line, CD, is cutting through or intersecting at the point M. Since M was the midpoint, this line CD is considered a segment bisector to the whole segment AB because it's cutting it into those two equidistant, those two congruent pieces. Once we understand what a midpoint is, we can use the midpoint formula, but we can also use the distance formula to help us find midpoints as well. We're going to be looking at how these work on a coordinate plane xy using two different points that we label as x1, y1 and x2, y2. So for our distance formula, the distance between 2 points would be found by saying d equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. So you take your second x value and subtract the first x value from it, square that number, and then add it to the second y value minus the first y value squared. Add the two numbers together, take their square root, and that will be the distance from this point to this point. Our midpoint formula would tell us the exact middle of these 2 points on the graph. So we can estimate that it would be about here, but if we know the actual coordinates x1, y1, x2, y2, we can use this formula, and it is actually the midpoint of its x2 plus x1 all over 2, and then y2 plus y1 all over 2. We add the x values together, so x1 plus x2. That's going to get the whole length between them, and then we divide it by 2. It's kind of like taking the average between the two numbers that we were at on the x-axis. We do the same thing to find the average between the y values, so we add the two y values together and divide them by 2. So make sure you have these two formulas written down. Go ahead and pause it to make sure that you have them written down correctly. All right, so now we're going to use these two formulas to figure out some of the distances of segments and their midpoints. So in this picture, we've got points A, B, and C all in a coordinate plane. Point A is at the coordinate 1, 2. Point B is at the coordinate -4, +3. And point C is at the coordinate 0, -1. We're going to use these along with the two new formulas we just went over to find their distances and their midpoints. So the first example we're finding is the distance between A and C. So the segment AC, how long is it? Well, we can kind of look at it on the graph, and it's hard to count here because it's actually a diagonal line. We can say it looks like maybe it's about 3 units, but we can't say for sure. So this is where the distance formula helps us. We're going to plug in all the numbers that we know. So we're going to take the distance formula, and it's x2 minus x1. Well, point A was at 1, 2, and point C was at 0, -1. This would be my x1 and my y1. This is my x2 and my y2. So I plug them in. x2 was 0 minus x1, which was 1. We're going to square it. We add it to y2 minus y1, and we square it. So x1 and x2 was this part, and y1 and y2 were the next part. So we're just plugging in that formula using that points that we know. Then we just have to do some algebraic steps here. We need to subtract in the parentheses. So I get -1 inside, and I'm going to square it. And then on the inside of this, I get -3, and I will square it. This becomes -1 squared is 1, plus -3 squared is 9. So we get a final answer of square root of 10. This square root can't be simplified anymore, so the distance between points A and C on the graph would be root 10. And if you know your square roots, square root of 9 is 3, so square root of 10 is just above that. And we had estimated that it looks like it's about 3 units, but it wasn't precisely 3, it was actually the square root of 10. So we were pretty close. Now to find the midpoint of those two segments, we would need to use the midpoint formula. So we take our same two x1 and y1, x2 and y2, and plug them into the midpoint formula here. So my x2 value was 0, and my x1 value was 1. I'm going to divide it by 2 once I add them together to find their average. For y2 it was -1, and y1 was +2, so I'm going to add them together and take their average, so divide it by 2. 0 plus 1 is 1, and it's all over 2, so we can leave it as 1/2. -1 plus 2 is 1, all over 2, so 1/2. So our midpoint of that segment would be 1/2, 1/2. So between that would be about here and here. 1/2, 1/2 is about this point that I'm putting here, and that does look like it is about halfway between that segment. So I'd like you to try the next two examples on your own, so you can go ahead and pause the video to find the distance of segment AB and then the midpoint of segment AB. When you're ready, go ahead and press play to listen to the results. So in this next example, point A we're using, but we're also using point B. So I would first label what your x1 and y1s are. So A was at 1, 2, and then point B was at -4, 3. Labeling these ahead of time as x1, y1, and x2, y2 will help you plug these into the formulas. So the distance between A and B, we'll use the distance formula. x2 was -4, minus x1 was 1. We're going to square it, and then we add it to y2 minus y1 and square it. We use our algebraic skills and we follow the order of operations. So first we get -5 in the parentheses squaring, and then 3 minus 2 is 1 squared. This gets us 25 plus 1 under the radical. So our answer here is the square root of 26. The square root can't be simplified any further, so that would be the distance between those 2 points. To find their midpoint, we're going to add their x1 and x2 together. So that's -4 plus 1 all over 2. And then we do the same with their y values, so 3 plus 2 over 2. And then we just have to simplify, so -4 plus 1 is -3 over 2, and 3 plus 2 is 5 over 2. Since these fractions are simplified, we can just leave them in fraction form, or you can change them to a decimal. And then I'm going to put that into our graph up here. So between the points A and B, we were looking at the point -3/2, which is -1.5, and then 5 over 2, which is 2.5. And that would be about here. That does look like it's about halfway between point A and point B on that graph. So graphing it once you do the algebraic steps might be helpful for you to kind of make sure that your answer made sense. We can also kind of estimate here between A and B. There was about what looks like 5 boxes, but we did move up 1 there. So it was about 5. Our answer was the square root of 26, which is really close to the square root of 25, so that is a reasonable answer for that. We have 2 other examples using this, so if you want to give them a try, go ahead and pause the video, otherwise you can keep on listening. We are reading the first one as the midpoint of segment JK is M at 4, 2, and one endpoint of JK is J at 0, 1. We need to find the other endpoint K. So you have a couple ways to do this. The first way you could do is to put this on the graph. So I'm putting point M at 4, 2, and point J is at 0, 1, which is right here. So we're trying to figure out where the other endpoint K would be. Well, M is the midpoint, so this segment is starting to kind of go in this direction, and we're looking for about where the midpoint would be. You might be able to kind of estimate it there, but then you can check it algebraically to make sure that it makes sense. So the way that I'm going to do that is to use the midpoint formula to help me with this. I know that the midpoint comes from adding your 2 x values together and dividing by 2, and you get your y values added together and then divide by 2. So I'm going to do these one at a time. I know that the x value of my midpoint is 4. and I know one of my x values is 0. So to find the other x value, I'm going to plug it into that formula for x. So right now I'm just using my x values to help me solve this. So when I solve this, I can multiply by 2 on both sides. That gets me 8 equals 0 plus x1. So 8 equals x1. Then I can do the same thing with my y values. I know that my midpoint y value is 2, and one of my endpoint y values was 1. So I'm going to say the midpoint was equal to 2, and that was from getting 1 plus whatever y1 is, all divided by 2. So again, I'm going to multiply by 2 on both sides. I get 4 equals 1 plus y1. I'm going to subtract 1 from each side, so 3 equals y1. That would mean that my end point that I was looking for at point K should be 8, 3. And if we check that on the graph, 8, 3 would be right here, and that looks like it's just in line with what we had been saying, so this seems like a reasonable answer for our midpoint. So you can use the graph to help you make sure that the answer you got makes sense. Finally, the endpoints of segment LF are L at -2, 2, and F at 3, 1. The endpoints of segment JR are at J, 1, -1, and R, 2, -3. Determine if the segment LF and segment JR are congruent. So to figure out if they're congruent, we need to know how long they are. We'll use the distance formula to help us solve for the distance of LF and the distance of JR. So to use that, we're going to plug in our distance formula. So my x2 for the first one is 3, and my x1 was -2. So I needed to subtract a negative. Remember, that just means we end up adding it. We take our y2, which is 1, and subtract our y1, and then square that. This gets me 5 squared plus -1 squared, which is the square root of 25 plus 1. So a final answer of the square root of 26 for our distance of LF. Now we have to repeat the process for the segment JR to see if they're congruent. So we're going to plug in x2 is 2 minus x1 is 1. We square it. y2 is -3 minus -1, which is our y2. We add them because we had minus a negative. This becomes 1 squared plus -2 squared. So we end up getting 1 plus 4 underneath the radical, which gets us square root of 5. That also cannot be simplified, and we were questioning whether LF is congruent to JR, while the square root of 26 is not equal to the square root of 5, which means that this would not be true. Those two segments are not congruent.